Okay, so I'm creating this video here to help you do some homework, and I want to share my screen with you so you can see. I'm going into the homework for our support of math modeling in MyLab Math. And I just want to take a look at some problems in Module 4. So let's take a look. I want to look at problems starting with 24. And this problem involves linear regression. So we have 10 students in a graduate program, and they were randomly selected. Their grade point averages, or GPAs, when they entered the program were between 3.5 and 4.0. The following data were obtained regarding their GPAs on entering the program versus their current GPAs. Use linear regression to find a linear function that predicts a student's current GPA as a function of his or her entering GPA. So here's our data. Now, I want to call your attention to a phrase, current GPA as a function of his or her entering GPA. So the current GPA is a function of the entering GPA. What that means is that the current GPA depends on what the entering GPA is. And so the current GPA is the dependent variable, and the entering GPA is the independent variable. So that refers to the independent variable being the x-axis. So these data points here on the top are the x values, and then the current GPA depends on what x is, whatever that input is, your output. So if your input is 3.5, your output is 3.6. And the output is the dependent variable because it depends on what your input is. So just so you understand which one represents the horizontal axis, the x values, and which one represents the y values. So once you've determined that, you're going to use your calculator to enter this data. And this depends on the model of your calculator, how to do this. So we all have different calculators, presumably, although the ones recommended for your course are the TI 83, 84, or the TI 83, or the TI 84 plus. So those four different models, and they have to be, you cannot use a symbolic calculator, that's not allowed. So make sure you have one of those four models that's approved by the university for this class. Okay, so once you've determined the model, then what I recommend is, and I'm going to share my screen again, we're going to go to YouTube. And I typed in linear regression TI 83, 84. And so you're going to put your model in, whatever model you have. You're going to type in linear regression, and then you're going to put the model of your calculator in, and it's going to bring up a video. So, for example, this video, I'll play that for a little bit. So this is where you're going to be entering your data on this screen. And L1 will be your input for your X values, and L2 will be the output, your Y values. So you just enter them in, and then you follow the instructions to get the linear regression. So I'm going to pause this for a second and go back to sharing my screen to the homework. Okay, so here we have the homework. And again, look for the words function of. The variable that comes before, so current GPA as a function, these are the function values, which are the Y values, of entering GPA. Those are the X values. Okay, let's look at the next problem. Again, the dependent variable in this case is the cost of advertising and the number of products sold is going to be the independent variable. Or I got it backwards, sorry. The cost is the independent variable and the number of products sold is dependent. So your input is 9, your output is 85. So you're going to be listing these in your first list of data points, and then corresponding to each one of those, you're going to have in the second list these data points, and then you're going to follow the instructions for calculating the linear regression. There's also a document, a PDF file in the week module for your Math 1101 class that explains how to do this. But I think most of you all would prefer to watch a video, so I recommend that you just go to YouTube and do a search, whatever works best for you. So that's all that you're doing on these. If you have any difficulties with this, please reach out to me and I'll see if I can help you. That's all for now.